All right, this is the analog meters part 2. So here we're going to explore the importance of connecting up a analog meter if it's going to be used to measure voltage or current in the correct way so that we don't damage the meters, okay? And it comes down to some fundamental principles. The fundamental principles when it comes to analog meters are their limitations based on the amount of current that can flow within them, okay? And the internal resistance of that meter as it's going to be connected. Now, resistance is measured in ohms, okay? And if I look at an ammeter, okay, the purpose of an ammeter is to measure current. All right? So by measuring current, we want that not to add extra resistance into the circuit. We want it to be basically as unseen within the circuit as possible. In other words, we just want it to display the amount of current flowing in that circuit without adding extra resistance, which would then drive or determine a greater or a lesser amount of resistance in that circuit. Okay? And we do that by connecting ammeters up in series. So if they're connected up in series, they have to have a very low internal resistance. Okay? Contrary to that, we would have our voltmeters. Whoops. Voltmeters. They are used to measure voltage. Okay? They have a very high internal resistance, and therefore they need to be connected up in parallel. I'll get into series and parallel in a minute. Okay? So connected in parallel, and they have a high resistance. Why do they have to have a high resistance? Because current takes the path of least resistance. If we connect up a meter, we do not want that meter to be have a lower value of resistance than that in the circuit, and therefore subject all of the current flow to the meter leads themselves. Okay, we want this to have a massive amount of resistance so that current won't flow, or the bulk of the circuit current won't flow through that meter. Okay, and instead you will just get the meter or the voltage potential across 2 points within the circuit. So if we look at our moving coil and pointer, voltmeter or ammeter, it doesn't matter. The premise is still exactly the same, but if I wipe this stuff away and focus on our ammeter circuit, so this is my ammeter circuit. And if we start with a negative terminal and a positive terminal here, my ammeter gets connected up in series. So this is my ammeter, and we're going to then go up to our load. So this is our load, okay, and here's my source. All right, source meaning my battery. So we have an amount of current flowing and leaving this negative terminal here. Current is then flowing this way, and down this way, and then back to that source. This is my positive. So based on this, we can look at the polarities that happen along the way in this circuit. We've got current flowing from negative to positive the whole way along. All right? Now, this point here and that point there are the only parts where you have technically the true negative within the circuit. Everything else after that becomes an instantaneous polarity. All right? So this is a true negative. As current crosses that load, this becomes a positive or an instantaneous positive based on the direction of current flow. This current is going negative to positive, negative to positive, negative to positive the whole way along. Okay? But much like if you've ever taken your jumpers, had to jump start a car or something like that, and you have two batteries, you take the negative terminal on one battery and you connect it up to the negative terminal on the other battery. Those are technically still the same conductor, so those are both negative, okay? So as we cross this, that becomes our instantaneous positive because it does not have a true connection to that positive there yet. We still have to go through our load. So as we come along here, we're still bumping negative to positive in polarities. This is a negative because this becomes a true positive as it is connected back to the source that way. Okay, so those are my circuit polarities and how they work. Now, if we look at my ammeter, remember the moving coil from the previous lesson, we need to make sure that we have this terminal here and that terminal there connected up to the appropriate polarities in order to make sure that this ammeter is going to point upscale. So we want that pointer to be heading in that direction and not downscale, okay? And if that's the case, we need to ensure that I have this as my negative side and this is my positive side in DC. In AC, or alternating current, it doesn't matter because the polarity is constantly changing 60 times a second, okay? From negative to positive, all right? So there's no issue with connecting up meters in series or in parallel in an AC circuit because the polarities don't matter, all right? But in DC they do, and that's what I've drawn here. A battery source, that's a direct current source, meaning current only has one direction that it flows continuously in. Okay, so here I have my ammeter connected up in series, and why do I call it in series? Kind of like the chain link fence or something, or a chain. You know, you've got chains linked together. If they only have one path to go, in other words, only one link on either side of it, we series them up, okay? If I started dangling a bunch of extras hanging off of it and give it alternative methods to go, that becomes a parallel portion there, okay? So ammeters, because of their low resistance internally, they need to be connected up in series with that circuit. If we connected it up in parallel, current takes the path of least resistance. That would mean all of the circuit current would bypass the load here and go through an ammeter if we connected it up in parallel. The meter we do connect up in parallel, however, is my voltmeter. Okay? So my voltmeter is connected up in parallel, and that ensures that because of its high resistance, it doesn't affect the circuit or the current within that circuit, but it will measure the potential difference between that point and that point. Got that? Okay. So my polarities, because this is an instantaneous negative and that's a true positive, this has to be a negative and that has to be a positive. All right? Now that's important that when we connect these up in the lab circuits and things like that we connect up voltmeters in parallel with the correct polarity, ammeters in series with the correct polarity so that we don't damage them in either way. Okay? When it comes to ohm meters, their polarities don't matter because we're measuring a resistance based on the internal battery of that meter. However, we never connect up an ohm meter to a live circuit because the ohm meter has its own internal battery source. And if we connect it up, it'd be like plugging a battery into a wall socket where you would plug your cell phone charger into or something. You are going to damage that battery. All right, so that would not be a good situation. Okay, so that's part 2 of analog meters. Next, we'll step into the lab. Thank you.